Nikalyte are selling SERS sensors. Why is this exciting? SERS sensors allow you to measure an incredibly small amount of a molecule. You simply take an amount of that material, drop it onto our SERS sensor, and then you sit that in front of a Raman spectrometer and measure the signal. So SERS technology has been around for many decades. It's a way of amplifying Raman signals. Normal methods of making SERS use chemical approaches, colloidal chemistry. Nikalyte uses a physical approach. We use a nanostructured metallic surface, and by looking at Maxwell's laws and quantum electrodynamics, the Raman signal is amplified by up to 10 to the 18 times. First thing is we need a metal that's quite stable in oxygen, so gold is a very good example of that. The other reason is that you need a material where when you stimulate electrons in the nanoparticle, you have inherently low losses in that metal, and gold and silver are very good examples of such materials. So can using a SERS sensor tell you how much, or be a quantitative measurement? The answer presently is no to that. SERS can tell you if there's a tiny amount, a medium amount, a high amount, but at Nikalyte we're working on techniques where in the future we will be able to quantify amounts of material, which is very exciting. Nikalyte's technology is unique. Our competitors normally use chemical techniques, which means that the nanoparticles that are left on the sensor are agglomerated, all bunched up. Other manufacturers use expensive lithographic techniques, which are very, very difficult to scale. Our technique is a unique physical technique which makes the sensors perform extremely well at a very low price point. So SERS has been around for decades. Why hasn't it found its place in the market at scale? Because of the chemical methods used to form these sensors, there are three main problems. It's uniformity, reproducibility, and lifetime. So Nikalyte has been working for the past 2 years, and we have solved all three of these barriers. So Raman spectroscopy can be used for process control if you want to keep an eye on, for instance, the makeup of a pharmaceutical drug. It is very useful in a production line. Presently there's a fentanyl crisis. Last year there were over 100,000 deaths per year from fentanyl, and we think so far this year there's been over 16,000 pounds of fentanyl seized at US borders. So this is a huge application where we can look for trace amounts of fentanyl. Other applications would be the pharma industry for drug discovery, the food industry for food doctoring, contamination, also the environmental aspect, looking at pesticides in water and pollutants in air. So these are just a few examples of the ginormous potential for SERS sensing. In the future, Raman spectrometers are now becoming pocket-sized and economical. The price point for a Raman spectrometer is now dipping below $10,000, and that will go down to a few $1,000s soon. They're very portable and ruggedized, so they can be carried in the pocket, and that combined with our sensor, it makes for a very powerful, immediate, in the field solution compared to expensive laboratory techniques.